Hello, everyone, and thank you for attending today's webinar, 3GPP Release 20, Completing the 5G Advanced Evolution and Preparing for 6G Standardization, presented by Qualcomm and Fierce Network. I'm Rebecca Kushmetter, and I'll be moderating this webinar. Before we get started, I have a couple housekeeping notes for you. Additional resources are available in the handouts window, and if you close one of the windows and need to reopen it, you can click the name on the top bar, and it should pop right up. The webinar is being recorded. It will be available on demand within 24 hours. And to learn more about our speaker today, you can head on over to the speaker bio window and read more there. And finally, there will be Q&A at the end of the presentation. If you have any questions for our speaker, enter them anytime in the Submit Questions window. All right, I'd like to go ahead and introduce our speaker today. We're going to be joined by Juan Montoya, Vice President of Technical Standards at Qualcomm. Please go ahead.
Thank you very much, Rebecca, and good morning, good evening, good afternoon, everyone. Yes, I'm excited to be here. It's effectively 10 days after the closing of the plenary meetings where most of the material that I will be presenting today was decided. So the presentation is structured in three main sections. The first one is going to be a little bit of a check of where we are with respect to 5G and its evolution. So it's a bit of a snapshot. And then the second and the third part is really the summary of what happened 10 days ago. We had the plenaries for 3GPP in Prague in the Czech Republic. And in those, we effectively agreed the scope for 5G Advanced Release 20, as well as the scope of the technical, the approval and the scope of the technical studies for 6G, which are also scheduled to start in Q3 of this year. We will complete the presentation or finalize with some questions. Now, let me tell you, I mean, probably it's already well known, but the mobile data consumption continues to grow. There are these estimates that probably will grow 4x by 2030. And the key drivers for this increase are effectively broad use of 5G, improvements on these video quality, which actually require higher data rates, XR becoming more and more mainstream, and then cloud gaming. Also, not least, it's also the impact of AI into the cellular networks. And there are these estimates that it is expected at some point it will account for almost 1/3 of the data traffic that goes through cellular networks by 2033. This is actually increasing also overall the cellular WAN traffic, right? As we say here, 5x to 9x from 2023 to 2033. So just about the time when 6G will come. Now, if we look into where we are globally, right? Well, first of all, the number of smartphones that are already have been shipped for 5G smartphones are 3.2 billion. That is 2 out of 4 people on Earth, basically already equivalently have received a 5G smartphone. Over 630 operators are already investing in 5G. And then actually you look out of those, more than 350 have deployed 5G services. More than 160, almost 170 are using fixed wireless access based on 5G. And also over 160 operators have deployed standalone, 5G standalone, which is the one that effectively are investing on a standalone. 73 are already launched, is the one that really delivers the promise of 5G. If you look into now 5G Advanced, which is accounting for the the 3 last releases of 5G, already over 25 operators in 15 countries are investing. So the numbers actually speak by themselves. And now if you look into, I mean, there is a lot of commentary around 5G, whether it's good or bad or less than expected. But the truth of the matter is the 5G is delivering data rates and system capacities never seen before, actually, from any metric that you look into. I mean, overall traffic demand that they serve, as well as the data rates that basically capable of. Everything started with non-standalone. It was the kind of a bit of a shortcut to enable this acceleration of 5G deployments. relying on 4G core networks and 4G deployments as basically an anchor. And then, of course, it did, to some degree, maybe then delay the introduction of a standalone, as we saw in the previous slide. A lot of deployments still are transitioning from non-standalone to standalone. Standalone is the one that is going to deliver the true value of 5G. For example, things like RedCap requires a standalone. Also, slicing and network slicing, it's a very important aspect of 5G architecture, also requires a standalone, and some other goodies of 5G only come in this standalone form. As I said, from release 18, release 15 was the first one for 5G, release 18 being the fourth one was the first for 5G Advanced, and there are already new services, new type of devices introduced, and also, for example, satellite communications also enabled. Now, if we move into what Qualcomm, where Qualcomm is in terms of actually commercial availability, we just announced very recently the launch of this Qualcomm X85 platform. It's a 5G modem RF solution, and actually, interestingly, has a built-in 5G AI processor. That AI processor will actually operate through implementation-based solutions based on AI/ML type solutions for improved performance. In addition, I mean, this solution is going to support all frequency bands. I mean, from the lower FR1, so up to 6 gigahertz, but also a millimeter wave, and provides satellite connectivity. This solution can be used for different, very diverse device types, from regular smartphones to fixed wireless access, mobile broadband, PCs, and even industrial IoT type applications. I mean, you can see the data rate, the downlink peak speed that the device, the envelope that the modem will support is in the excess of 12 gigabit per second. So very exciting. And now you look into the overall timeline and where we are more or less halfway between 5G and 6G. We're in 2025. Mainstream, actually, 6G deployments are expected in 2030. There could be some early trials before that. And then, as I said earlier, there were 3 releases covering 5G. I mean, as we know it, release 15 initial release, 16 introduced quite a bit of vertical and capabilities that were not supported, like native positioning and license, integrated access backhaul positioning. And release 17 also introduced, for example, important services like satellite, RedCap, reduced capability. And then 5G Advanced came with release 18. And actually, there were a number of very important projects, like, for example, network energy savings, but also very important studies that got materialized or are getting materialized in release 19, which actually we are about to close. Indeed, the physical layer group already considered release 19 functionally frozen, and it will close by the end of the year, 2025. Now, as I said at the beginning of the presentation, what we are going to be talking today is this approval of release 20 scope for 5G Advanced. This release is going to last 18 months, which is the duration of the last couple of releases, 18 and 19. And also, it basically launches the technical studies on 6G. Before this time, actually, already there were a couple of important workshops. There was a use case workshop in May of last year, in 2024, and there was actually an overall 3GPP workshop in March of this year, where actually companies across basically industries, operators, vendors, verticals were invited to come with what to show basically what they felt 6G should offer and actually how. So exciting to be here. I mean, release 20 studies are going to last 21 months. So basically, they will go a little bit beyond the completion of release 20. And then release 21 will be the first 6G specifications and its completion, right? The completion at this point is expected to be not earlier than March 2029. Now, if you look into the basically the timelines from another, I mean, now from more different groups, and actually both the release 20 5G Advanced as well as the release 20 6G studies, we're going to basically start discussions in the physical layer starting in August. We already started discussions on the plenary level, and there is an important project that we'll discuss in a bit that is developing a technical report for 6G with scenarios and requirements. Those requirements will entail both ITU requirements as well as 3GPP internal requirements, as we'll discuss shortly. And then on 5G Advanced, as I said, is the last release that is exclusive to 5G, because of course release 20 is going to now have both studies on 6G as well as 5G Advanced. And we are expecting probably 5G will evolve farther beyond release 20, but within the scope TBD at this point. So there is actually, let me take note of this important contribution. It was submitted in a prior plenary meeting, and all the main industry players from the vendor and operator community co-source, and is showing the desire of 3GPP industry to basically come up with lean and streamlined standards for 6G. So we want to dimension appropriate set of functionalities, because we understand it's very important to decide those functionalities that will be necessary in day one of 6G, minimizing adoption of multiple options for the same functionality and avoiding excessive configuration. So I started my career at Qualcomm almost 29 years ago. It was at the inception of 3G, and actually 3G was also very configurable. That actually, the pains of the deployment of 3G when led to a very simple and a very lean 4G specification. It seems that now that got forgotten and 5G came about, and then I'm expecting 6G to again rectify and then actually do something with much leaner, with less options, and then focusing on really things that do matter for the user experience and for the operator value. And this is the RAM plenary study that I just mentioned. So 6G has a variety of studies. I mean, there are TSG level or plenary level studies, and I'm focusing here on the radio one. And then there are working group level or technical studies, for example, at the radio working groups as well as the system architecture working group. As I mentioned, there are two important aspects: the ITU kind of requirements, which come from outside 3GPP, they come from ITU, and 3GPP will deliver because there will be an IMT 2030 proposal from 3GPP into the ITU, but also because the 3GPP community worries also about its own unique needs from operators, from vertical industries. There is a very, very important, I would even say more important set of requirements that come from within 3GPP. And those are the ones that are basically called out in this second part of the RAM plenary study description. So we want to basically look into improving existing and introducing new services. We want to basically look into the applicability of less legacy services to the 6G radio and define radio requirements. And then we want to develop effectively this new system that at the end, everything can be encapsulated into, in my opinion, two axioms. Number one, improving user experience. The device, the user has to really notice an improvement, whether it's on data rates, on coverage, on power savings, whatever it is, very seamless terrestrial, non-terrestrial connectivity, and it has to also add value to the operator. Operators at the end are the ones investing into the deployment of these networks. And in that sense, it is important for them to find new ways of finding new sources of revenue. Also, it is important for them to reduce the CapEx and OpEx for running these networks, deploying and running these networks. In that sense, energy efficiency for the network, network automation mechanisms, actually not being able or not necessitating to densify the networks, basically have a common grid of site base station sites as we moving up to higher frequencies and so on. So all those will contribute, and then enabling a very easy introduction of new services, which hopefully will bring new sources of revenue for those operators. And when I say operators, I also extend to vertical industries. I mean, as we know, I mean, NTN, broadcasters, automotive industry. Those are indeed also customers of what 3GPP is delivering. Of course, there is an oversight a little bit on this other project that will be at the working group level, more on the technical side, on the how solutions. So this is more what are we looking for, the what's, and then the other one, the working group are looking into how, right? I mean, how are we delivering into those requirements? So there is a little bit of an oversight function that is expected, and of course, there are a couple, indeed, four very, very high level questions that we want to address sooner rather than later. One is the fundamental 6G radio design, overall high-level aspects of the 5G to 6G migration, also applying lessons learned from the 4G to 5G, the overall RAN architecture and interfaces, including this RAN core interface, and then how are we going to basically address AI/ML in a unified, holistic 3GPP way, in a unified framework. Now, moving now back to 5G. So 5G, as I said, release 20 is the third release of 5G Advanced, and indeed it comes with a number of improvements. I mean, those improvements, I must say, they are relatively, I mean, the release is a bit more modest because, of course, a big chunk of the release 20 is going to be devoted to the 6G studies. But nevertheless, it's actually a fairly good set of actually attractive features for operators and vertical industries. So let me actually walk through the main ones. I mean, there are MIMO multi-antenna systems are going to be further evolved. I mean, get into the sixth phase of evolution since the introduction of release 15 MIMO. We will see there is mobility enhancements, and we'll discuss the details in a second. Very meaningful improvements on satellite, and we'll also discuss. Coverage remains very important, very key aspect for network operators, and improving uplink in particular remains important, and is going to have also a project in release 20. AR interface, something that for the radio was started in release 18 with a study. There has been a normative phase in 19, and there is a second part of that normative phase in release 20. And then SON-MDT and also AI ML for network automation is also part of release 20. Now, for new type of devices and use cases, there are three projects worth mentioning. One is ambient IoT. Ambient IoT, we'll discuss a bit more later, but it's been introduced in release 19. So there will be already an ambient IoT solution at the end of the release. Integrated sensing and communication, I would say, is bridging towards 6G. It's actually a new type of service, but already a very simplified mode of it will be introduced in 5G Advanced, release 20. And then XR, which also we had projects in to enable optimizations for XR traffic in a couple of releases already, 18 and 19. We're going to have further improvements in 20. So now going one by one, starting with MIMO. MIMO, there are really two main areas. One is uplink capacity improvements via SRS. So SRS is the sounding signal. There are really two main aspects within that, which is the cross-slot SRS resources. So going across slots from an uplink slot to the special slot subsequent. There is also enabling capacity improvement with these SRS hopping patterns that actually are revisited in release 20. And then for CSI or downlink improvements, we have this early trigger of sounding CSI or CSIRS triggering for these devices that transition from being idle or inactive, which is effectively zero idle, to connected, or enabling secondary cells, which is effectively the cells that are not truly active when carrier aggregation it's already ready to be launched. Then for large number of CSIRS ports beyond 32, there is another objective that we'll try to simplify, actually to reduce the overhead. So we will actually, what we'll do is we get into sparser densities in the frequency domain to basically entail or encompass less CSIRS overhead. As you know, CSIRS is the signal that is used for this enabling these measurements on the downlink of the basically the channel conditions, so that actually it can enable reports from the devices on these non SRS or non reciprocity based MIMO transmissions. So now into mobility, there are two projects of importance. One is the regular mobility, and in that sense, the last couple releases from release 18, the focus has been on this lower layer trigger mobility, or LTM. Some people call it L1, L2 mobility. Mobility historically has been a layer 3 procedure, so this is why this is called L1, L2 or LTM, a lower layer trigger mobility. And there are basically attempts to reduce delays when there is actually SL switch. There is also in these layer 1 measurements and reporting, we want to enable the reconfiguration of those via MAC-CE, which actually would be faster than it is allowed right now. And then the other project of importance is this AIML mobility, or AIML applied to mobility. A study has or is taking place still in release 19, and it focuses on L3 mobility. And L3 mobility is all about measurements and triggers for events. In those, actually, it is what we are going to do is enable a specification or normative support for those RRM measurements, radio resource management measurement predictions, as well as this prediction of measurement events. And then we will also revisit the release 19 general framework that has introduced the lifecycle management for AIML models. And in that sense, equally applicable for device side as well as network side AIML models. We will see whether actually those will need to be extended to address this mobility-based AIML. Now, coverage. Coverage is a relatively small project, and there was no release 19 project for coverage enhancements, but there is coming now in release 20 with a couple of those proposals. Effectively, one is PRATCH a repetition with different transmission beams, which will enable the network to actually attempt to give indications which beams are best when the device sends on multiple beam directions, this pseudo random access channel. There is also enabling this dynamic PUSCH, the uplink data channel repetition, through the compact DCI format for uplink grants, and then extending the pi by 2 BPSK modulation order, which is the most power efficient because it effectively has even a negative power reduction. So basically there is a power boost associated with this modulation order to basically more entries in the MCS tables. MCS tables are the modulation and coding scheme tables, the ones that determine what modulation order and channel coding rate the transmission is taking place on. So right now we are only enabling very, very few entries. It's one or two. We're going to do enable from release 20 more than that. Now, if you look into AI, I already mentioned in release 18, we studied it. In release 19, we already are doing providing normative support for a few use cases. One that we left out was one that was continued being studied in release 19, which is the two-sided CSI compression. So CSI compression, it's actually the only use case that was identified requiring two-sided models. That means a model resides at the device and a model resides at the network, and they are very tightly coupled. So this is actually going to be done for the use case of no temporal aspect. So it's simply a spatial and frequency compression. And it's going to basically be done, very importantly, I mean, then this second bullet, I'm not going to go word by word, but it's all the study item agreements that were associated with enabling this use case. But what is important is one aspect that was put almost the main reason why this was not converted to work item in release 19, along with the other use cases, was some concerns at the time of how we were going to do inter-vendor training collaboration. And a lot of actually progress was made during the release 18 studies. And in that sense, there is here the possibility or actually the recommendation to the normative phase for this fully defined or specified reference model, considering this scalability of those models as one possibility, but also looking into standardized data sets, format and contents, plus this data set exchange, which actually it would be almost opposite to what I described earlier, because the first one is reference model gets specified just for the test equipment vendors, you know what to test against. But this one treats the model as a black box, and what the 3GPP will provide is the input-output of the model of that black box, and that is considered this data set. So basically, those are the two extremes. If you want, leaving a lot of freedom to the basic implementation of the model, or leaving no freedom to that implementation. And there is another scheme somewhere in between that would enable not the model itself, but the model properties, and then some parameter exchange through what is called data set. And then for ng-run, which is this network automation through AI/ML, the only case that actually is going to be addressed is mobility enhancements. And you will see later on also in SonMDT, this is the use case of interest. A satellite dimension, there are two projects, very relevant, very compelling in that sense. Satellite operations in 3GPP, 5G, or even 4G with IoT NTN have always assumed the availability of GNSS. GNSS is think about it as GPS. So you know position, you know the time, then you know when the satellites are coming. So then actually you can narrow down this initial access of satellite quite a bit. And we are really basically lifting that requirement, and then try to study what would be required to basically enable communication from initial access. So from basically cold start, as we call it. And also potentially even if you look connectivity, GNSS connectivity while you are in connected mode. So very relevant study. It was going to be done for an RNTN assumption, but of course is physics. It's about Doppler and then uncertainties in frequency and so on, which are applicable to all type of systems. So then actually solutions might actually in the future be applicable to IoT NTN as well as 6G NTN. IoT NTN, on the other hand, the main purpose is to enable voice over geostationary satellites. I mean, right now, geostationary satellites running IoT NTN is really limited to texting. Now we want to basically extend that to voice, and in that sense, there will be this control plane, a user plane is effectively where is the data going to be put in, as well as radio enhancements, in particular semi-persistent scheduling for uplink and downlink, so that the downlink control overhead and uplink control overhead is reduced to the maximum extent. There is of course, there will be these studies, or actually not, there's necessary modifications to the RSC connection setup procedure and emergency calls. And then lastly, a PC1 is the maximum power class that 3GPP defines, is 31 dBm. But there are some systems out there that actually are going up to 37 dBm. And actually, we're going to study the feasibility on trying to do a higher power transmissions also for IoT NTN, trying to get as close as possible to this competition of 37 dBm. So now ambient IoT, I also mentioned, it's important because release 19 defined this device type 1, passive device. It's a backscatter type of technology. And we're going to extend to active devices in release 20. In release 19 also is only topology 1, the reader, basically the one that reads the tags, are base stations. Now topology 2, which is going to be addressed in release 20, is going to be the UE, and the UE eventually is connected to the network as well. So topology 1 and topology 2 are in scope for active devices. Then there is a study in parallel which will look into taking ambient IoT outdoors. I mean, everything that has been done so far assumes indoor deployment on cellular license spectrum. And in that sense, there is a very controlled environment, if you wish. If you take the things outdoor, there will be much more interference scenarios, and those will be studied in this release 20 study item on ambient IoT for outdoors. XR. XR is becoming more and more in XR devices an AI agent. You could actually tell your glasses, take a picture, or you could take your glasses, who is this person I'm looking at? And in that sense, it's going to create some traffic that right now we don't know the characteristics of. And this is what this study will do, is actually try to characterize the AI traffic. And then actually once we have characterized it, we will know what to do basically as potential enhancements, in particular for the uplink. And this is what the focus of this project will be. So it's a bit exploratory, nonetheless, very, very important in preparation of XR going mainstream. And then Isaac also will discuss this in 6G. There is a baby step for 5G Advanced, which only considers monostatic. That means the same entity transmits and receives, so kind of the radar type of operation. But then it's only the base station. It's only applicable to the base station. So right now, round one will be doing the studies on the adequacy of the channel model for drones, and then actually the kind of accuracy and the measurements that one would actually need to specify for these links between base stations for basically enabling this joint characterization of these measurements that may come from different base stations. Bistatic and UV involvement, for example, will only be done in 6G. And then let me close it with 5G Advanced with these two projects. Sun MDT will focus on mobility enhancements, and then there will be probably later on in release 20 a drone project that is supposed to be very small. We won't even have a project for it. It will probably be done in a single meeting. Now, moving to 6G, I think it's important to realize that we have a lot to say here. So we are going to do effectively an entire look into what 6G is desired to be. So first of all, 6G in 6G times we are expecting the communication and compute will get blur. I mean more and more blurred. So we are going to use the networks for actually moving data that would enable compute, and then depending on the capabilities on the entity, you will actually do compute locally, or actually you will move the data so that the compute can be done at the edge of the networks. But anyways, we are going to see again a lot of these gains of actually moving data for enabling compute operations. In that sense, these are, I call them the axioms of the project. We are going to define a non-backward compatible radio. That means that if you put a 5G on that particular system, it will not operate. I mean, you will need an upgrade a device. We're going to look into a very compelling set of functionalities from the beginning, minimizing options. We're going to identify extensibility and deliver superior performance. And extensibility could actually be in many domains, right? Different device types, but also how the system could evolve over time. And then we're going to address all the spectrum up to 52.6, which was the original scope of 5G. I mean, later on in release 17, we extended to 71 gigahertz, which was what it was called FR2-2. That is right now not in the scope of this day one interest. We are here touching every single aspect of the system, from the physical layer to the protocol, architecture, new services, and so on. So let's jump now into one at a time. So starting with a common technology framework. We want to have a common technology framework, something that will work not just for one use case, but it will work for a large variety of use cases. Terrestrial, non-terrestrial. There will be effectively macro cells, low bands, mid bands, whether it's FDD or TDD, and millimeter wave still will be relevant. And then there is a lot of emphasis, as I said earlier, user experience improvements, and then adding value to the operators. So there are importance on coverage. There is importance on energy savings at the device and at the network. There is important on actually enabling different device types effectively, and enabling the possibility to extend something that was designed primarily for broadband to be used in other verticals. And then actually trying to again getting into the operator value, trying to significantly improve the spectral efficiency, right? So if you increase the spectral efficiency, the cost to deliver every bit per second will actually go down for the network operators. So how are we going to do this? I mean, we're going to revisit every single aspect of the system, as I just said, right? So what do we have in the physical layer to do in 6G? So we're going to look into waveforms. We're going to look into channel coding. We're going to look into numerology for wider bandwidths. And we're going to look into enhancements on basically hierarchy operation, MIMO, duplexing, energy efficiency, and then spectrum aggregation and other physical layer designs. In the waveform, OFDM is actually the natural choice of OFDM family, OFDM and DFT spread OFDM, because they live very well with this multi-rad spectrum sharing that is going to be important on this migration. And then on channel coding, I wanted to say that it's not just about performance, but also, very importantly, this complexity performance trade-off, something that maybe is not being super emphasized in the past, but it's key for actual implementations, right? So in that sense, I think that is one aspect that we are looking forward to revisit and actually make sure that we have, at least on this peak rate type of capability, a possibility to reduce largely this complexity. Now, into other areas of the air interface, protocols. So we have user plane and control plane. We have, some people talk about data plane, by the way, for things that are not user nor data control, for things like sensing, AI/ML. Those, even though they are not explicitly called out, I mean, those will have to be addressed. We're going to have to look into these access stratum security aspects. So security is very important. I think it's indeed a very hot topic. And more and more companies believe that we should bring down in layers below PDCP security, the security framework, whether it's MAC or even physical layer. We're going to look into overall RAN architecture aspects, including the RAN to core network functional split, interface, stack, and procedures. Also, the internal RAN functional split and interfaces, protocol stacks, and procedures as well. Mobility has actually an objective standalone, because, of course, is along with coverage, is a very, very important aspect of any cellular operation. Into now, it's very important, we have realized, to come up with an air interface that gets then properly tested. And in that sense, that testing only is getting done by these performance requirements, which are at the device and at the base station. So in that sense, we have a special emphasis on this RF, or what we call 6G RF design, both from the point of view of actually coexistence studies, as well as tightening up the performance requirements. As we know, as we move up in frequencies, and the new spectrum for 6G, it's only higher in frequency than in 5G. We're going to have more antennas, so these multiple antenna and active antenna systems become very, very important, and actually those have to be also properly characterized and tested. And then on the device side, we're going to see more and more hybrid beamforming schemes. So kind of a little bit the best of the FR1 and FR2 as we know it today, with digital and analog beamforming respectively, into some new forms of actually hybrid beamforming. So in the baseband, also the testing will be important, where there is radio resource management, the mod performance, and then also the testability aspect, in particular when it comes to the introduction of new functionalities like AI/ML. In that sense, it's actually important to actually handle new types of actually spectrum and what we call irregular bandwidths. A lot of the work has been done recently in 3GPP for 5G is addressing these non-multiples of 5 megahertz, and then defining a new frequency range for this island that lives between FR1 and FR2. FR1 goes until 6.25, but FR2 only starts at 24.25, right? So in between, we call it FR3. We also have to define that frequency range. Migration, I already mentioned. Already there's lessons learned from the past. I mean, 4G to 5G migration was actually somewhat painful. DSS, dynamic spectrum sharing, maybe did not deliver as well as it was meant to be. The reason for it is also the common signals that were transmitted or were required to be transmitted in LTE. Those will no longer exist in 5G. So in that sense, MRSS, multi-radio or multi-rad spectrum sharing is expected to operate much better. And then whether we need to aggregate on top of actually the 6G radio, the previous RAT, the 5G, it will depend on the operator assets, right? I mean, if the spectrum, 6G spectrum actually is sufficient, and then we could do MRSS in a low band, maybe that is sufficient. I mean, and actually that would be probably the best and most efficient way to introduce 6G, but maybe it's not sufficient in every market, in every operator environment. And in that sense, we may need to actually come up with an aggregation of 5G, inter-rate aggregation of 5G and 6G spectrum. And there are two solutions that right now we believe should be studied. One is dual connectivity based, which is effectively what we did in 5G with NSA, and also dual stack, which is effectively trying to leverage the multi-SIM operations that already exist also in 5G. Now, if you look into AI, there are two parts. One is identifying existing use cases. So actually the physical layer working group chair already sent the agenda for August, and this is in the agenda. It's a kind of a call for proposals of actually techniques that would benefit from an AI ML implementation. And then actually, so let's identify those actually promising use cases. And then once we have identified, trying to zoom in and then actually characterize them and compare them with maybe conventional schemes, as well as trying to identify what is the standards impact. Also, it has to be put in context with what we have done in 5G, with a general framework that has been introduced, with even the lifecycle management that has been introduced for that general framework, and even these extensions that have been done for the use cases that we are already addressing in 5G. Integrated sensing and communications, I already mentioned briefly earlier. There is a mini project in 5G, monostatic base station based, but it's going to evolve into actually bistatic UE involvement beyond the base station and even base station to base station, right? So how ISAC is going to basically enable new services, it still has to be seen. But indeed, there are actually some very nice ideas where there is flight control for drones, or actually detection of, for example, as shown here, of people that get closer to base stations and so on, maybe to enable turning them on off. And in that sense, very promising as a service. Also on architecture, this is kind of a summary that we have from the SA2 is the architecture group, and there is a lot of work on effectively revisiting. I must say there are many operators, as you remember, that we discussed earlier, that still have to deploy standalone. Standalone is the one that connected the 5G radio to the 5G core. So with non-standalone, the core that is being used is the 4G core called EPC. But yes, now the general framework for this study will go into first assessing basically what is the architecture needs for 6G. There is a variety of use cases, and there is already an architecture coming up from 5G. And then what are the core network enhancements that would be required? And in that sense, there are indeed important aspects that will need to be addressed: migration and interworking, whether it's actually with 5G, or even potentially still to be confirmed whether we go back all the way to 4G. Wireless AI, I already mentioned earlier from the radio perspective, but also from the system architecture perspective. It's important to address AI in a unified framework under the same umbrella across use cases. There is also these AI agents that are becoming more popular. Integrated sensing, this is the counterpart on the sensing from the radio perspective. Data framework, this covers these aspects that actually relate to efficient and scalable data handling, where there is data collection, distribution, processing, storage, and then exposure. This data is very important, as you know, and then actually what 3GPP is trying to do is to come up with frameworks that would enable standard-based solutions. Of course, one could also think about over-the-top solutions that do not require standardization, but actually there is an overall desire in 3GPP to come up with these standards-based solutions for data management. Distribute compute, I already mentioned 6G. One of the main topics of interest is this compute and communications. So there is computing for device, core network, and application server in 6G, and then coordinating that compute, basically even splitting and then sharing, right? Terrestrial, non-terrestrial networking, actually, it's important how to basically interoperate and allow for this seamless interoperation between terrestrial and non-terrestrial. And then lastly, very important to look into the Internet of Things. Internet of Things, it's if you look into the definition of Internet of Things may actually come with different answers. 5G natively, the closest to Internet of Things that has done is this reduced capability. And then actually, which was introduced in release 17, was further enhanced in release 18. But actually, it has really not introduced any low power wide area network system. For that, what we did in release 16 is connect the LTE developed in release 13 originally, narrowband IoT and eMTC or CAT-M to the 5G core. Now there is a lot of desire, a lot of push for having an LPWA design in 6G and even more to design it from the very beginning, from day one. This actually will have to be discussed. I already mentioned the different device types as being one of the potential sources of new revenues for the operators. So IoT could be one additional type of device. What we want is all these type of devices are effectively served by a single radio, a single system, as opposed to have bespoke implementations that are optimized for one or other use case. And I think this is concluding the presentation. If you want more information around what Qualcomm's views are on 6G, there is this website, www.qualcomm.com/6G, where you will find, I think, much more information of interest. So with that, many thanks to everyone for your attention, and talk to you very soon.
All right, thank you so much. As you said, now it is time for Q&A. We have time for a few questions before we come to the end of our time together here. So let's go ahead and get started. To begin, most of the 5G Advanced Release 20 projects are enhancements for existing capabilities. What's your view of their role? Will they be deployed or are they foundational to 6G?
I think this is an interesting question, and I believe it's both. Some of them I think are clearly a bridge towards 6G. And I think just to give an example, ISAC, in my opinion, is one prime example for that. To some degree, AI/ML for the air interface is probably also bridging with 6G. Whether it will, I doubt it will be broadly deployed, but at least we know when 6G comes, we have a very good handle of how AI/ML for the radio should be done, right? Because we already have 3 releases of actually work. The entire 5G Advanced series, 18, 19, 20. And those learnings actually would be applied towards 6G. If we had not done it in 5G, we would start from scratch in 6G, which would be then missing out this opportunity to have it ready from day one. So these particular projects that I just mentioned are very important because they are almost defining 6G, and actually they are being defining in 6G because they were already fully understood in the 5G time. There are others, on the other hand, that I think they have very good chances for deployment. And I think in particular, I'm pretty fond of the NTN ones. I think the NTN, both for NRNTN, this GNSS resilient. Some people call it GNSS less, but some people feel it's a bit aggressive of a term. But effectively, is really what it's trying to address, right? If you don't have GNSS, if you don't have positioning at a point in time, for whatever reason, right? Because GNSS requires a line of sight and then you lost line of sight, or because there is a spoofing of the GPS or the GNSS signal, or whatever the other reasons, still the now providing the ability to make to basically enable connectivity. It's, I think, a huge step function in functionality that doesn't exist before release 20. And then voice over geostationary satellites is also a kind of almost like a miracle, right? I mean, something that is 36,000 kilometers away, and then you will be able to sustain a voice connection, right, on a very narrow band frequency allocation. It's also very, very important. I mean, we know that NTN IoT is being deployed. It's actually enabled in the US, and you can actually, if you get a new model, a phone model, I mean, from some, I mean, if you get a Galaxy 25 in the US, you can get a narrowband IoT NTN working on your device. So I believe it's only for texting, but of course, imagine now that you could even do voice. So I think, and then there are other projects. I mean, we'll see. Still, the jury's out to see whether they will be deployed or not. But I think with that, I conclude the answer. I mean, if we can move to the next one if we have time.
Sure, we can take a couple more questions here. Were there any important 6G studies that were excluded from the initial release 20 scope?
No, as probably people may have seen, the scope of the study is very broad. I think nothing has been really left out. I mean, I'm trying to improvise now an answer. I mean, maybe a couple of researchy type of topics that maybe some research circles have been talking about, like terahertz or these visible light communications or VLC. Those are topics that are not in day one, and actually there is no mention. As I when we went over the spectrum applicability of 6G, we mentioned FR1, we mentioned FR2-1, which goes up to 52.6, and we mentioned FR3, which is the in-between frequency range from 7 to 24 gigahertz. But it's true, we do stop at 52.6. In 5G, we already stopped going beyond 100 gigahertz or beyond 71 gigahertz to be strict because we stop at 71. And in that sense, that is not there. There was not sufficient appetite, particularly from operators. And actually, the license regime of that spectrum still is to be seen, right? Because the propagation is such that maybe licensing, either unless it's a very local license, might not be required, right? I mean, there is no notion of a nationwide or a county-wide license for this type of spectrum. That is probably the only one that I can think of. Everything else is up in the scope, and I think it's good and it's positive because it enables effectively companies, starting with operators, telling us what they want to see in 6G, but then vendors in particular trying to come up with solutions to enable and to bring up a very compelling 6G proposition from day one.
Oh, right, thank you. I think we have time for one last question here
All
before we
right.
have to wrap up for today. Finally, in your opinion, what is the most interesting 6G study that's going to begin this summer?
I mean, there is probably one. I'm going back to the round one or the physical layer working group chair agenda that he sent very recently, a couple of days ago, to the reflector. And I already made note of that, mentioning that there is this call for proposals for AI ML based kind of use cases, and effectively just to explore what could it be that it's compelling enough for gains and so on. And that is actually a nice one. But there is another one which is fairly generic, which I thought it was very ingenious, which is pain points for 5G. So it's inviting companies, and again, maybe operators are in the best position, our industry vertical industries also. What are the pain points of 5G? Why 5G maybe is not as good as one would want, or what can 6G do to make 5G much better, right? So this is, I think, a very important aspect that will need to be very carefully studied. And I do have my own expectations. I do believe you look into the user experience. Really, what I think matters the most is, for example, coverage. It's very, very important. So enhancing coverage for the devices. Also, power efficiency. So you want your battery not to drain. I mean, actually last as long as you can. Along with coverage is consistency in data rates. So not that because you are very close to the base station, you get a very high data rate, and if you get farther away, you drop dramatically in data rate. That's another one. And then maybe access, what we call instantaneous access to broadband. Effectively, imagine going from deep sleep when you have a very, very power efficient mode of operation for your device. You want to jump to gigabit per second as quick as possible. And this is something that we've not been able to address in the previous generations, either 4G or 5G. It takes a lot of time to basically wake up the modem, to basically wake up or activate cells as carrier aggregation gets configured, and secondary cells get activated. And in that sense, there is, I think, a very good opportunity to tune these procedures and enable these dual, very, very power efficient modes, along with the ability to go from 0 to 100, right, very, very quickly. In my opinion, that would be a tremendous improvement in user experience. And I'm actually positive that 6G can do that.
Well, thank you so much. And we are out of time for today, but we appreciate you taking the time to be here with us. If you submitted a question and we weren't able to get to it, we'll do our best to get back to you in person after the webinar. And just a reminder, this has been recorded. It should be available to watch on demand within 24 hours. Thanks again for joining us today, and we look forward to seeing you next time.
Thank you, Rebecca. See you all.